In trigonometry 3, we're going to look at finding angles when we have two sides. Now we know we could use Pythagoras to get the third side here, but if we're not asked that, we still go about things exactly the way we learned in trigonometry 2, where we label our triangle. H and A touch off the angle, which leaves O over here. Now in this, we're not looking for one of the sides, we're looking for the angle. So write down what we have. We have O and A. And if you're consistent, you'll write SOHCAHTOA at the top of the page, and this will tell you which ratio to use. O and A has to be tan. So we can say that the tan of A is equal to O over A off to the side, which is 4 over 3. Tan is the only ratio that can have a value greater than 1. This is greater than 1. So on your calculator, you would type in the inverse tan of 4 over 3, and that would give you the angle A. And your answer would be A is equal to 53.13 degrees, which would be to one decimal place 53.1 degrees, and to the nearest whole number 53 degrees. Just read the question carefully and see what they're asking you. Now, say we were asked for the angle B. We could do this maths again. We could do all of this again, or we could just say B is equal to 180 minus 90, which is the right angle, minus 53 if we take the whole number, which would leave B being 90 take away 53, which would be 37 degrees. Now let's check that using the maths that we've already used so far in this lesson. I'm going to write the triangle again. I'm going to put B at the top. I'm going to put my 4 on and my 3 on. Now, if we label our triangle, this time H and A touch off the angle still, but you can see what has happened with A and O. They have swapped places. So we're going to use tan. We have O and A, or A and O, so we're going to use tan. So we say the tan of B is equal to, off to the side, O over A, and then fill O over A in, 3 over 4. So the inverse tan of 3 over 4 is equal to the angle B. And if you type this into your calculator, you're going to get B is equal to 36.87 degrees. Now, we rounded this off to 37, and if we rounded this to one decimal place, it will be 36.9. And if we round it to the nearest whole number, will be 37 degrees. So a couple of different ways to approach this question depending on what you've been asked. So now let's have a look at when we are going to use sine and cos when we have the two sides. So let's label our triangle and find this angle A. H and A touch off the angle, which leaves O over here. So what have we got this time? We have H and O. So we're going to use, you've written down SOHCAHTOA. Do it 10 or 15 or 20 times and you'll always remember it. You'd be amazed the amount of people that get the ratios wrong because they just don't spend the time putting in the basic work required to learn these ratios. So we're going to use sine. So the sine of A, and we're going to see something in this question that relates back to part 1, and will then bring us on to what are called Pythagorean triples and how we can kind of create them. So the sine of A is equal to O over H from here, which is 6 over 10. So if we type into our calculator the inverse sine, we don't have to simplify it to 3 over 5. The inverse sine of 6 over 10, we're going to get 36.86 degrees. Now, does this look familiar to you? 37 degrees or 36.87 degrees. This is actually 36.869, which would give us 36.87 or 36.9 or 37 degrees. So it's the same angle that we had up here. And I want to introduce to you why in this lesson. If we use Pythagoras, let's call this side x to get x. X is equal to, we have the diagonal, go back to trig 1, 10 squared minus 6 squared was one of the examples we used. So x equals to the square root of 100 minus 36. But your calculator will do it for you. If you want to practice these in your head, I would advise it, but your calculator will do all these calculations for you. So x is equal to 8. So if I draw this triangle, hopefully you'll identify a similarity between this one and one of the ones that we used at the beginning of Trig 1, where the sides were 3, 4, and 5. So what's happened with these triangles? 5 has jumped to 10, 3 has jumped to 6, and 8 has jumped to 4. They've all been multiplied by 2. So the ratio of the sides are in the same proportion. So you can see how the angles will be the same size. Okay, let's do an example with cos, and then I'll test you with one of each. So katoa. So how do we set up a question with cos? We're looking at the A and the H. So maybe practice setting up a question yourselves. It's definitely the best way to get good at maths. So we want to have A and H. So here's H. I'll give it 15. Depending on where the angle is, will determine where A. We saw A and O switching around between these two sides. So depending on where you put the angle will determine where A is. So if we put the angle here, A would have to be down the bottom. So that's called a 10. So what do we have? We're not going to write down what we have until we label our triangle. H and A, well, we have H and A, you can see straight away. We don't need the O. So we say the cos, we're going to use cos. We're going to say the cos of A is equal to A over H off to the side. Be consistent. 10 over 15. If you write 15 over 10, have that memory that a cos ratio cannot be greater than 1 because the hypotenuse is the longest side, which is on the bottom, and that's the reason why. So the inverse cos of 10 over 15 will give me the angle A. And if we type this into our calculator, going to get 48.1896, so 189, 48.19, or 48.2, or 48 degrees. Don't forget your degree symbol, which I do a lot. So now, pause the video when you see the next three questions. One will be sine, one will be cos, and one will be tan, and work out the three angles labeled A. So pause the video at this point. Write the three questions into your copies. Have your calculator ready. Write SOHCAHTOA at the top of your page and practice these three questions. Okay, question 1. Label the triangle. H and A always touch off the angle. So you can see here we have, you can see with the two straight sides. If you can see the two straight sides straight away, you know you're going to be using tan, but I would be insistent that you do it the same method each time. So we have O and A, so we're going to use tan. So the tan of A is equal to, off to the side, O over A. The consistency is the key in maths. So 1 over 2. So the inverse tan of 1 over 2 is equal to A. So on our calculators, typing this in, A is going to give us 26.565 degrees, which will be 26.57 degrees, or 26.6 degrees, or 27 degrees. Second question, label your triangle. H and A touch off the angle. We can see H. If you're not sure which one is H, just draw an arrow away from the right angle. It's the one opposite. H and A. So in this case we have H and A. You can see I'm doing it the same way every time. It builds consistency, it builds confidence. What are we going to use? H and A. Cos, you say. So the cos of A is equal to A over H off to the side, which is 7. Sorry, you all have identified a mistake here. The hypotenuse has to be the longest side. So if you have attempted this question with the incorrect information, try it now with 14. I left out the 1. 7 over 14. So cos inverse cos of 7 over 14 is equal to A. So A is equal to 60 degrees, and this is something you've seen already. 7 over 14 is a half. The cos of 60 is equal to a half, so hopefully you're seeing some repetition going on. So I tell my class I left out the one on purpose to see was anyone paying attention, which wasn't the case this time. I just made a mistake. So we label this triangle. H and A touch off the angle. H and A. So we've got O. So what do we have this time? We have H and O. So we're going to use H and O, the only one that has it. So we're going to use sine. So the sine of A is equal to, off to the side, O over H, 2 over 25. So the inverse sine of 2 over 25 is equal to A. So A is equal to a tiny angle, 4.5885, 4.5885, which is 4.589, or 4.59, or 4.6, or 5 degrees. Now, if you imagine this is a really tall ladder standing up against the wall, and it's only a little bit away from the wall, 2 compared to 25, you could see that the angle that it would create at the top of the wall is quite small. And in the next lesson, we're going on to see these real life questions with ladders on walls or the height of buildings, but the maths involved is what you've learned in Trig 1, 2 and 3. So master Trig 1, 2 and 3, and then move on to the next lesson.